January 24th, 1961, 00:12 hours Eastern Time, Seymour Johnson Air Force Base Operations Center, Goldsboro, North Carolina. Technical Sergeant Donald R. Walsh reviewed the pre-flight checklist for Chrome Dome Mission 8-4, a routine Strategic Air Command airborne alert scheduled to begin in 2 hours. The mission briefing specified B-52G tail number 580187, call sign T-16, departing Seymour Johnson at 0300 hours for a 24-hour patrol route over the eastern United States and Atlantic Ocean. The bomber would carry 2 Mark 39 thermonuclear bombs, each with a yield of 3.8 megatons, as part of SAC's continuous airborne alert program maintaining nuclear-armed bombers on patrol 24 hours per day. Walsh initialed the checklist. Everything appeared routine. Chrome Dome missions flew continuously, maintaining American nuclear deterrent readiness by keeping bombers airborne with live nuclear weapons, ready to proceed to Soviet targets if war orders were received. The mission T-16 would fly was identical to missions flown hundreds of times previously. What Technical Sergeant Walsh could not predict, what no checklist could anticipate, was that 8 hours into the mission, at 00:24 hours on January 24th, B-52G tail number 580187 would experience catastrophic structural failure at 10,000 feet altitude over Faro, North Carolina, 12 miles north of Goldsboro. The aircraft would break apart in flight. The crew would attempt to bail out. And the 2 Mark 39 thermonuclear bombs, each 260 times more powerful than Hiroshima, would separate from the disintegrating bomber and fall toward a tobacco farm owned by the Mattox family. One weapon, designated Bomb 1, would descend with its parachute deploying, landing relatively intact in a muddy field. The weapon would be recovered the following day, safed and removed. The weapon's arming sequence would be examined and would reveal that 5 of the 6 safety interlocks had activated during the fall. Only one switch, the final ready safe switch, had remained in the safe position. One switch, operated by a single mechanical interlock, had prevented a 3.8 megaton thermonuclear detonation over North Carolina. The second weapon, Bomb 2, would descend without parachute deployment, impacting a waterlogged field at terminal velocity and penetrating approximately 180 feet into the soft earth. Recovery operations would retrieve portions of the weapon, but would be unable to reach the thermonuclear secondary stage, which would remain buried 180 feet underground, where it remains today. To understand how a B-52 broke apart over North Carolina and dropped 2 hydrogen bombs, one switch preventing detonation, one must understand Strategic Air Command's Chrome Dome Airborne Alert Program, the B-52G bomber and its capabilities, and the specific sequence of mechanical failures that caused structural breakup over a peaceful North Carolina farming community. Strategic Air Command in January 1961 maintained continuous airborne alert under Operation Chrome Dome, a program implemented in 1958 to ensure a portion of America's bomber force remained airborne at all times, invulnerable to Soviet surprise attack. At any given moment, approximately 12 B-52 bombers were airborne, carrying live nuclear weapons, flying predetermined routes over the United States and international waters. The Chrome Dome concept addressed a fundamental vulnerability in nuclear deterrence. Bombers on the ground could be destroyed by Soviet ICBM attack before they could launch. Placing bombers in the air eliminated this vulnerability. Even if Soviet missiles destroyed every American airbase, the airborne bombers would survive and could proceed to Soviet targets, ensuring retaliation. But Chrome Dome created a different risk. Bombers carrying live nuclear weapons flew continuously over populated areas. Mechanical failures, crew errors, or accidents during routine operations could result in nuclear weapons falling on American or Allied territory. The risk was assessed as acceptable given the deterrent value of maintaining airborne alert. The B-52 Stratofortress was SAC's primary heavy bomber in 1961. Designed by Boeing and first flown in 1955, the B-52 was an 8-engine, swept-wing jet bomber capable of carrying up to 70,000 pounds of weapons over intercontinental ranges. The aircraft measured 157 feet long with a 185-foot wingspan and operated with a crew of 6: pilot, co-pilot, navigator, radar navigator, electronic warfare officer, and tail gunner. The specific aircraft involved in the Goldsboro incident was B-52G, tail number 580187, manufactured in 1958 and assigned to the 4240 1st Bombardment Wing at Seymour Johnson Air Force Base. The bomber had accumulated approximately 2,400 flight hours over 3 years of service and was considered fully mission-capable. The crew consisted of experienced SAC airmen: Major Walter Tulloch, 36 years old, aircraft commander with 15 years military flying experience; Captain Richard W. Radin, co-pilot; Captain Adam Mattox, navigator; Major Eugene Holcomb Richards, radar navigator; Staff Sergeant Francis Roger Barnish, in-flight maintenance technician; and Staff Sergeant Calvin E. Snap, boom operator. All were experienced bomber crew members who had flown dozens of Chrome Dome missions. The nuclear weapons aboard were Mark 39 thermonuclear bombs, a weapon design that entered service in 1957. The Mark 39 used a 2-stage design with a fission primary, triggering a fusion secondary, achieving variable yields between 2.5 and 3.8 megatons, depending on configuration. The weapons measured 12 feet 4 inches long, 3 feet 4 inches in diameter, and weighed 700 to 600 pounds each. The 2 Mark 39 bombs aboard tail number 580187 were configured for maximum 3.8 megaton yield. Each weapon contained approximately 400 pounds of highly enriched uranium in the primary stage and a quantity of lithium deuteride fusion fuel in the secondary stage. Both bombs were fully assembled and capable of nuclear detonation if properly armed and detonated. The weapons incorporated multiple safety systems designed to prevent accidental detonation. Safety 1. Manual arming requirement. Physical switches inside the weapons had to be manually set to arm position by crew members before the weapons could detonate. The switches were accessible only through panels, requiring tools to open. Safety 2. Cockpit arm safe switch. A switch in the cockpit, controlled by the pilot, had to be moved from safe to arm position to enable the weapon's electrical systems. Safety 3. Barometric switches. The weapons contained pressure-sensitive switches that prevented arming below specified altitudes, ensuring weapons could not arm while aircraft was on the ground or at low altitude. Safety 4. Timer circuits. Electronic timers prevented arming for specified periods after electrical power was applied, ensuring weapons had time to conduct self-diagnostics before arming was possible. Safety 5. Radar altimeter arming. The weapons required detection of ground approach by radar altimeter before final arming would occur, ensuring weapons armed only during actual delivery toward targets. Safety 6. Ready safe switch. The final interlock, a mechanical switch that had to transition from safe to ready position, enabling the firing circuits that would trigger the high explosives. All 6 safety systems had to be in the correct state for detonation to occur. If any single safety remained engaged, detonation was impossible. The multiple redundant safeties were designed to ensure that even in catastrophic accident scenarios, nuclear detonation would not occur. Chrome Dome Mission 84, designated call sign T-16, began routinely. At 0257 hours on January 23, 1961, B-52G tail number 580187 started engines at Seymour Johnson Air Force Base. At 0327 hours, the bomber launched, carrying its crew of 6 and 2 Mark 39 thermonuclear bombs totaling 6 megatons of yield. The mission route took the bomber northeast along the Atlantic coast toward Canada, then southeast over the Atlantic, then southwest back toward North Carolina, completing a roughly rectangular patrol pattern. The route was designed to keep the bomber within range of tanker aircraft for in-flight refueling while maintaining position to proceed to Soviet targets if war orders were received. At 0645 hours, approximately 3 hours into the mission, T-16 conducted its first aerial refueling, taking on 27,000 pounds of fuel from a KC-135 tanker over the Atlantic Ocean east of Virginia. The refueling was routine and completed without incident. At 11:30 hours, T-16 conducted its second refueling, again taking approximately 27,000 pounds of fuel. The bomber continued its patrol route, with crew members rotating through rest periods, eating in-flight meals, and conducting routine systems checks. At 18:45 hours, approximately 15 hours into the mission, T-16 was scheduled for its third refueling. The bomber rendezvoused with tanker aircraft over the Atlantic Ocean east of Beaufort, North Carolina. The refueling connection was established and fuel transfer began. At 18:47 hours, the boom operator on the tanker conducting the fuel transfer noticed what appeared to be fuel streaming from the B-52's right wing. The fuel appeared to be coming not from the refueling receptacle, but from somewhere on the wing structure itself. The boom operator immediately aborted the refueling connection and notified the B-52 crew. Major Tulloch, in the B-52 cockpit, checked his fuel quantity gauges. The right wing tanks showed rapid fuel loss, approximately 1,000 pounds per minute dropping from Tank 3, the outboard right wing fuel cell. Tulloch immediately declared an emergency and requested vectors to the nearest suitable airfield. The fuel leak was coming from a structural failure in the right wing. During the refueling connection, the forces transmitted through the refueling boom to the aircraft structure had exceeded design limits on a wing section already weakened by metal fatigue. A 10-foot section of the lower wing skin had cracked, creating an opening through which fuel was escaping. The crack was not immediately catastrophic. The wing structure retained sufficient strength to support the aircraft's weight, but the fuel leak was severe. With 1,000 pounds per minute escaping, Tulloch calculated he had approximately 30 minutes of flight time before fuel exhaustion. Seymour Johnson Air Force Base was 75 miles southwest, approximately 12 minutes flying time. Tulloch turned toward Seymour Johnson and began descending from 29,000 feet altitude. If the wing structure held and the leak didn't worsen, he could reach Seymour Johnson with sufficient fuel remaining for landing. At 18:55 hours, descending through 18,000 feet, Tulloch felt the aircraft shudder. The shudder was slight but unmistakable. Structural vibration transmitted through the airframe. The wing crack was propagating. The weakened structure, subjected to aerodynamic loads during descent, was failing further. At 19:02 hours, descending through 10,000 feet, approximately 12 miles north of Goldsboro, North Carolina, the right wing failed catastrophically. The 10-foot crack, which had been confined to lower wing skin, suddenly propagated through multiple structural members. The wing failed in an area approximately 30 feet from the fuselage, the section containing the outboard fuel tanks and the outboard engine mounts. The failure was instantaneous. One moment the wing was intact. The next moment, a 30-foot section of right wing separated from the aircraft, taking with it 2 engines, 8,000 pounds of fuel, and the structural support for the right side of the aircraft. The B-52, suddenly missing one-third of its right wing, rolled violently to the right. The aircraft, no longer aerodynamically stable, entered an uncontrolled spin. Tulloch and Radin, both pulling on their control columns with full force, could not arrest the roll. The aircraft was uncontrollable. At 19:02:30, Tulloch ordered, "Bail out! Bail out! Everyone get out now!" The bailout from a B-52 spinning at 10,000 feet was chaotic and nearly impossible. The aircraft was rotating rapidly, creating centrifugal forces that pinned crew members to the walls of the fuselage. The hatches, designed to open outward, required pushing against the centrifugal force to escape. Major Richards, the radar navigator, was in the lower deck forward crew compartment. He managed to reach his ejection seat and initiated ejection. The seat fired, rocketing Richards out of the spinning aircraft at 19:02:45. His parachute deployed automatically. Richards descended safely and landed in a field approximately 3 miles north of Goldsboro at 19:05. He was uninjured. Staff Sergeant Barnish, the in-flight maintenance technician, was in the aft fuselage. He managed to open the aft crew door and jumped at approximately 8,000 feet altitude. His parachute deployed. Barnish landed near Faro, North Carolina, approximately 1 mile from where the aircraft would impact. He suffered a broken arm from hard landing, but survived. Captain Mattox, the navigator, was in the lower deck forward compartment with Major Richards. After Richards ejected, Mattox attempted to reach his ejection seat, but the centrifugal force was too strong. Mattox managed to crawl to the forward escape hatch and pushed it open. He fell through the hatch at approximately 6,000 feet. His parachute deployed. Mattox landed in a wooded area and survived with minor injuries. The remaining 3 crew members, Major Tulloch, Captain Radin, and Staff Sergeant Snap, were unable to escape the spinning aircraft. Tulloch and Radin remained at the cockpit controls, attempting to stabilize the aircraft. Snap, in the tail gunner position, was pinned by centrifugal force and could not reach his ejection controls. At 19:03:15, at approximately 3,000 feet altitude, the B-52's fuselage broke apart. The forward fuselage section, containing Tulloch and Radin, separated from the center fuselage. Both sections descended separately, tumbling and disintegrating further as they fell. At 19:03:52, the forward fuselage section impacted the ground in a wooded area 12 miles north of Goldsboro, killing Major Tulloch and Captain Radin instantly. The center and aft fuselage sections impacted approximately 400 yards away, killing Staff Sergeant Snap. During the aircraft's descent and breakup, the 2 Mark 39 thermonuclear bombs separated from the bomb bay. The weapons, weighing 7,600 pounds each, and secured by mechanical shackles designed to release when electrical power failed, fell free as the aircraft broke apart. Bomb 1 separated at approximately 9,000 feet altitude. The weapon's parachute deployment system, designed to activate automatically upon separation from the aircraft, functioned correctly. The drogue chute deployed at 8,500 feet, stabilizing the weapon's descent. The main parachute deployed at 7,000 feet, slowing the weapon's descent to approximately 25 feet per second. Bomb 1 descended under parachute and impacted a muddy field on the property of Walter and Clara Mattox, no relation to Captain Mattox, the navigator, at 19:04:30. The weapon struck the soft earth at relatively low velocity, penetrated approximately 5 feet, and came to rest partially buried and tilted at a 30-degree angle. Bomb 2 separated at approximately 7,000 feet altitude. The weapon's parachute deployment system malfunctioned. The drogue chute deployed, but the main parachute failed to separate from its storage canister. The weapon descended in an uncontrolled fall, tumbling and accelerating to terminal velocity of approximately 700 feet per second, Bomb 2 impacted a waterlogged field approximately 1,000 yards from Bomb 1 at 19:04:15. The weapon struck the soft, saturated earth at 700 feet per second, creating an impact crater 30 feet in diameter and 6 feet deep. The force of impact drove the weapon deep into the earth, penetrating through soft topsoil and clay, descending to a final depth of approximately 180 feet. The night of January 24, 1961, was cold and clear over Faro, North Carolina. Local residents, hearing and feeling the B-52 crash, called police and fire departments. First responders arrived at the crash site within 15 minutes and found aircraft wreckage scattered over several hundred yards of wooded and agricultural land. 3 bodies were recovered: Major Tulloch, Captain Radin, and Staff Sergeant Snap. At 19:45 hours, Air Force personnel from Seymour Johnson arrived at the crash site. The officer in charge, Lieutenant Colonel Robert L. Lady, was briefed by first responders on the crash and casualties. Lady then asked the question that would dominate the investigation. Where are the weapons? The B-52 had been carrying 2 thermonuclear bombs. The weapons were not visible at the main crash site. Lady immediately ordered search teams to expand the search area, looking for 2 7,600-pound cylindrical objects that should be somewhere within a mile or 2 of the crash site. At 20:15 hours, a search team found Bomb 1. The weapon was lying in a muddy field, partially buried, with its parachute draped over nearby trees. The weapon appeared externally intact. The parachute deployment had worked correctly, and the soft landing had prevented structural damage. Lady ordered an immediate safety perimeter around the weapon. No one would approach closer than 100 yards until a nuclear weapons disposal team arrived. The team, consisting of Air Force explosive ordnance disposal specialists trained in nuclear weapons, arrived from Seymour Johnson at 20:45 hours. At 2200 hours, under portable floodlights, the EOD team approached Bomb 1. The team leader, Captain William S. Culp, conducted initial external examination. The weapon appeared intact. The parachute had deployed correctly. The impact had been gentle enough that no obvious structural damage was visible. Culp ordered his team to examine the weapon's arming status. The Mark 39 had external indicators showing the state of various safety systems. The team's examination, conducted carefully to avoid disturbing the weapon, revealed the following. Safety 1. Manual arming. The internal manual switches were in safe position, confirmed by external indicators. This was expected. These switches were set before takeoff and required crew access to change. Safety 2. Cockpit arm safe switch. The external indicator showed safe position. This was expected. The pilot had not armed the weapons. Safety 3. Barometric switches. The external indicators showed these switches had activated during descent. The weapon had descended below the barometric arming altitude, and the switches had moved to arm position. This was unexpected and concerning. Barometric switches were supposed to prevent arming until deliberate bomb release at high altitude, not activate during accidental fall. Safety 4. Timer circuits. The external indicators showed timer circuits had completed their cycles. The timers, activated when the weapon separated from the aircraft, had counted down during the descent and had moved to armed status. This was extremely concerning. Timer circuits arming during an accident was not supposed to occur. Safety 5. Radar altimeter arming. The external indicators showed the radar altimeter had detected ground approach and had moved to armed status. This was even more concerning. The weapon's radar had tracked its descent toward the ground and had armed the weapon for detonation upon impact. Safety 6. Ready, safe switch. The external indicator showed safe position. This was the only safety that remained engaged. 5 of 6 safety systems had moved to armed status during the weapon's accidental fall. Only the final ready safe switch, a mechanical interlock operated by a single cam mechanism, had remained in the safe position. Captain Culp stared at the weapon's external indicators, processing what he was seeing. 5 of 6 safeties had failed. The weapon had armed itself during an accidental fall. 1 switch, 1 mechanical device had prevented a 3. 8-megaton thermonuclear detonation over North Carolina. At 22:30 hours, Culp reported to Lieutenant Colonel Lady, "Sir, the weapon is in safe status currently, but it came extremely close to detonating. 5 of 6 safeties activated during the fall. Only the ready safe switch remained engaged. If that switch had failed, or if impact forces had been sufficient to move it to ready position, the weapon would have detonated." At 2300 hours, the EOD team began safing procedures. The weapon's battery power was disconnected. The electrical firing circuits were physically disconnected. The weapon was confirmed to be in fully safe status, incapable of detonation, even if all switches moved to armed positions. At 0200 hours on January 25th, the weapon was lifted from the field using a crane and transported to Seymour Johnson Air Force Base for detailed examination. The search for Bomb 2 began at dawn on January 25th. Search teams, knowing the weapon had fallen without parachute, looked for impact crater or disturbance in the earth. At 08:15 hours, a team found the impact crater in a waterlogged field approximately 1,000 yards from where Bomb 1 had landed. The crater was 30 feet in diameter and approximately 6 feet deep at its center. The soft, saturated clay soil had closed over the crater, leaving only a depression visible on the surface. The weapon was not visible. It had penetrated deep into the earth. At 0900 hours, recovery operations began. A drilling rig was brought to the site and began drilling alongside the weapon's presumed path to determine depth. At 1400 hours, the drill struck metallic debris at 30 feet depth. The debris was retrieved and identified as portions of the weapon's outer casing, confirming the weapon's location. Recovery operations continued for weeks. The drilling revealed the weapon had penetrated to approximately 180 feet depth, far deeper than anticipated. The soft clay soil, saturated with water, had offered minimal resistance to the weapon's 700 foot per second impact velocity. The weapon had essentially liquefied the soil and driven itself deep underground. By March 1961, recovery operations had retrieved portions of the weapon from depths up to 100 feet. The primary stage, containing the uranium-235, was recovered. The high explosive lenses were recovered in fragments. But the secondary stage, the thermonuclear component containing lithium deuteride, remained beyond reach at approximately 180 feet depth. On April 15, 1961, the Air Force terminated recovery operations. The assessment was that continuing to pursue the secondary stage posed greater risks than leaving it buried. The drilling operations were destabilizing the soft clay, creating risk that the weapon components would descend further or that the drill rig would sink. The Air Force purchased a permanent easement on the property, prohibiting excavation beyond 10 feet depth, and closed the recovery operation. The thermonuclear secondary stage of Mark 39 Bomb 2 remains buried 180 feet underground near Faro, North Carolina, where it remains today, 64 years after the accident. The investigation into the Goldsboro accident was extensive, involving Air Force accident investigators, Strategic Air Command, and the Atomic Energy Commission. The investigation identified multiple findings. Finding 1, structural failure cause. The right wing failed due to metal fatigue in the lower wing skin, exacerbated by stress during in-flight refueling. The fatigue cracking had been present but undetected during previous inspections. Recommendation 1. Implement enhanced wing inspection procedures for B-52G aircraft, focusing on areas subjected to refueling stresses. Finding 2. Arming system design vulnerability. The Mark 39 weapons arming system was designed to arm during normal delivery profiles, which included separation from aircraft, descent through specified altitudes, and radar detection of ground approach. The system could not distinguish between intentional delivery and accidental separation. Recommendation 2. Redesign nuclear weapon arming systems to require positive crew action before arming sequences can initiate. Eliminate automatic arming based solely on flight profile. Finding 3. Ready Safe Switch reliability. The Ready Safe switch that prevented Bomb 1 from detonating was a mechanical device susceptible to impact forces. If Bomb 1 had impacted harder ground at higher velocity, the switch might have moved to ready position from impact shock. Recommendation 3. Redesign Ready Safe switches to require positive electrical signal to transition to ready position, eliminating possibility of mechanical shock causing transition. Finding 4. Parachute deployment failure. Bomb 2's parachute failed to deploy due to mechanical failure in the parachute canister release mechanism. The failure allowed the weapon to impact at terminal velocity, creating recovery difficulties. Recommendation 4. Redesign parachute deployment systems with redundant release mechanisms. The broader implication of the Goldsboro accident was that Chrome Dome operations, which placed nuclear-armed bombers on continuous airborne alert over the United States, created unacceptable risks. A single mechanical failure, structural breakup, or accident could result in nuclear weapons falling on American territory, possibly armed and possibly detonating. In 1968, following several additional Chrome Dome accidents, including the 1966 Palomares incident, where a B-52 collided with a tanker over Spain, dropping 4 hydrogen bombs on Spanish territory, the Defense Department terminated continuous airborne alert. Strategic bombers would remain on ground alert, able to launch within minutes, but would not fly continuously with nuclear weapons. The statistics of what was prevented by a single switch on January 24, 1961, quantify how close North Carolina came to nuclear disaster. January 24, 1961. Incident summary. Date, January 24, 1961. Time of breakup, 1902 hours. Eastern Time. Location, 10,000 feet altitude, 12 miles north of Goldsboro, North Carolina. Aircraft B-52G, tail number 580187. Failure cause, metal fatigue in right wing exacerbated by refueling stress. Weapons aboard, 2. Mark 39 thermonuclear bombs, 8 megatons each crew, 6. 3 survived, 3 killed. Bomb 1. Parachute deployed, landed intact, 5 of 6 safeties armed, 1 switch prevented detonation. Bomb 2. No parachute, impacted at 700 FPS, penetrated 180 feet, secondary stage never recovered. Current status, Bomb 2 thermonuclear secondary remains buried 180 feet underground near Faro, NC. If Bomb 1 had detonated, if the ready, safe switch had failed, yield 3.8 megatons detonation altitude, ground level fireball radius, 1. 8 miles, severe damage radius, 8 miles, includes Goldsboro, population 17,000, moderate damage radius, 15 miles, includes Seymour Johnson AFB, multiple towns. Thermal radiation radius, 25 miles, third-degree burns. Fallout pattern extending 100-plus miles downwind, affecting Raleigh, Durham, Fayetteville. Immediate casualties, 50,000 to 100,000 fallout casualties, additional 100,000 plus. Long-term contamination, eastern North Carolina, uninhabitable for decades. Economic impact, incalculable. Outcome casualties, 3 crew members killed in crash. Detonation, none. Contamination, none. Weapons recovered. Bomb 1 fully recovered. Bomb 2 partially recovered. Secondary stage remains buried. Margin of survival, one mechanical switch in one weapon. On January 24, 1961, at 19:02 hours, B-52G tail number 580187 broke apart over North Carolina due to structural failure in the right wing. The aircraft entered an uncontrolled spin. 3 crew members managed to bail out. 3 others died when the aircraft impacted the ground. During the breakup, 2 Mark 39 thermonuclear bombs separated from the aircraft and fell toward North Carolina farmland. Bomb 1 descended under parachute and landed relatively intact. Bomb 2 fell without parachute and impacted at 700 feet per second, penetrating 180 feet underground. Bomb 1's arming sequence was examined. 5 of 6 safety systems had activated during the fall, arming the weapon for detonation. Only one switch, the final ready safe switch, remained in the safe position. One mechanical interlock, operated by a single cam mechanism, prevented a 3.8 megaton thermonuclear detonation that would have devastated eastern North Carolina. The B-52 broke apart over North Carolina and dropped 2 hydrogen bombs. One switch prevented detonation. 5 safeties failed. One switch held. And the margin between routine accident and nuclear catastrophe was measured in the mechanical tolerance of a single cam-operated switch that remained in the safe position while everything around it moved to armed status. Bomb 2's secondary stage remains buried 180 feet underground near Faro, North Carolina, where it will remain indefinitely. The Air Force owns an easement prohibiting deep excavation. The weapon component sits beneath a North Carolina field, its exact condition unknown, its radioactive materials decaying slowly, a permanent reminder that nuclear weapons can be lost not just in oceans, but in American soil. A wing failed, a bomber broke apart, 2 hydrogen bombs fell, 5 safeties armed, 1 switch held. And eastern North Carolina survived because a mechanical cam in a ready safe switch, subjected to forces and conditions it was never designed to experience, remained in the safe position by a margin measured in millimeters and milligrams of mechanical force. The Goldsboro accident proved that multiple redundant safeties designed to prevent accidental detonation could fail sequentially during accident scenarios. The concept of independent safety systems failed when all systems responded to the same accident conditions: separation from aircraft, descent through arming altitudes, approach to ground. One accident scenario armed 5 safeties. Only the 6th, mechanically different from the others, remained engaged. 1 switch, 1 mechanism, 1 margin, and 8 megatons that didn't detonate over North Carolina because a cam-operated ready, safe switch, for reasons engineers still debate, remained in the safe position when every other safety had moved to armed.